So this question is about differentiating from first principles. Let's read and see what's going on. Given that theta is measured in radians, prove from first principles, so differentiating first principles, the derivative of cos theta is minus sine theta. And we're allowed to use the cos compound angle formula, as well as these two limits which may come into use later. Well, first, what does it mean to differentiate from first principles? Essentially, suppose we have some function f of x equals y. Well, by differentiating, we find the gradient of the function. Another way to find the gradient of the function is typically we find this y2 minus y1 over x2 minus x1. So the difference in y, or the change in y, over the change in x. Now, for the derivative, say f dash x, the formalism we use is that we think about the limit as h approaches 0 of f of x plus h minus f of x over h. So you can think of f of x as original y point and f of x plus h as our second y point. So we have y2 minus y1 at the top, and at the bottom we have x2 minus x1. Now x1 is x and x2 is x plus h, then x plus h minus x just leaves us with h, so we have an h on the bottom. So this right here, we're finding the gradient of the function, so we're differentiating here to find the gradient of the function. And we want to find the limit as this approaches 0, as that'll give us the exact derivative. And you can find this formula in your formula booklet. So now we know what we're doing. Let's differentiate cos theta and see what we get. So let's call this f of theta. Well, in that case, f dash theta, f of theta equals cos theta. And if that's the case, then f dash theta is going to be the limit as h approaches 0 of cos theta plus h minus cos theta all over h. Now, we want to expand out this cos theta plus h, and we can do so by the hint of the question, which is we're allowed to use a compound angle formula. So, cos theta plus h is the same thing as cos theta cos h minus sine theta sine h. And this is just the compound angle formula for cos. So continuing on with this, we have the limit as h approaches 0 of cos theta cos h minus sine theta sine h minus cos theta. This is all going to be over h. And now, what I'm going to do here is I'm going to group up the coses and the sines here and see what we're left with. So we're trying to find the limit as h approaches 0 of cos theta cos h minus cos theta all over h plus the sine part, which will be the limit as h approaches 0 of minus sine theta sine h all over h. Now what we can do next is, taking a look here, the limit only depends on h. So we're trying to limit as h approaches 0, which is what we can do is we can take out the cos theta from this part of the expression and take the sine theta from this part of the expression. So we just have h's in there. So doing that, taking out the cos theta, factorizing it out, we have cos theta times, I'll put this in square brackets, the limit, so h approaches 0 of, now cos theta cos h divided by cos theta is going to be cos h, and minus cos theta divided by cos theta is going to give us 1, so we have cos h minus 1 all over h. And the second part here, I'm going to take out minus sine theta here, so I'll have minus sine theta multiplied by the limit as h approaches 0 sine h over h. Now at this stage here, we can use the hints we're given in the question. So in the question, we're told that as h approaches 0, sine h over h approaches 1. Here we have h approaches 0, so sine h over h, well, that's going to approach 1. So this whole part just becomes 1. And then using the second part here, as h approaches 0, cos h minus 1 over h approaches 0. And that's what we have here. The limit as h approaches 0, cos h minus 1 over h approaches 0. Which means this part here is going to be 0. But in that case, we have cos theta times by 0, which means this part also goes to 0. So all we're left with now is just minus sine theta from here. And that's exactly what we need for the question. The derivative of cos theta is minus sine theta. So that's it for this question. Lastly, for the marking, for using the first principles derivative formula on the function, you'll get 1 mark. For using the compound angle formula successfully, you'll get 1 mark. For factorizing out the cos theta and sine theta, you'll also get 1 mark, as I've done there. That's 3. You'll get 1 mark for cancelling out the expressions and using the limits, so one is 0 and the other one is 1. So that's 4. And lastly, you get 1 mark for getting the right answer, for a total of 5 marks.